Welcome to another lesson in problem solving. This one will be on how to calculate the volume of topsoil needed to replant a lawn. You've seen a calculation of how much soil might be needed for a garden. We've done a calculation on how much gravel would be needed for a driveway. And this one gets a little more complicated because it's in a lawn which has, it's an odd shape. So this asks us to estimate how much soil will be needed if the owner of this property wants to replant the lawn and needs to cover all the area where the grass is supposed to be and the soil needs to be 4 inches deep. Topsoil is typically sold in cubic yards, so your answer should be in cubic yards. And the scale at the bottom of the picture indicates x feet. In this case, let x equal 35 feet. So that means the distance from here to here will be 35 feet, and we'll have to use that to estimate the area of the yard, the dimensions that will help us get the area. So you can see these little tufts. This is where all the grass is supposed to be, all in here. And so to get an estimate, I've drawn some border lines for this. So this looks like a fence line, and that's the property behind this home. So this gives us a little better picture, and I'm going to make this a little smaller. Now what's interesting is you've got to, once I get the image size set on my screen so they can make all those measurements, I don't want to change the image size. So I can, if it was here, it was nice because I can see it nicely, but it's a little, I can't see it all at once. So I'd like to make it as big as possible, which makes it easier to kind of do my measurements, but I don't want to be changing the size because this distance, this 35 feet, if we make the picture bigger, then everything changes by the same proportion. So we can change the size, and as long as I use this measure for 35 feet, if I make the whole thing a lot smaller, then my 35 feet is from here to here, and this got proportionally smaller as well. So as long as you keep this the same size throughout your measurements, you'll be fine. So the first thing I want to do is you need a ruler, and I have a nice clear ruler. They're pretty cheap to get about anywhere. But you don't actually even have to have a ruler. You could just cut a piece of, you can just use a piece of paper and mark how big this X is. You can mark that and just use that paper and say how many X's would there be. And if there's like 2.5 X's, you could make it 2.5 times 35 in this case. So X is 35 feet. So what I'm going to do on my measurement, I'm going to take my ruler, and I'm going to keep it this size. Let me make sure that, okay, this is all fits in my screen. I'm going to show you what I'm going to do here. I'm going to take my ruler, and I'm going to measure this, and that in inches. I'm using inches there. It doesn't really come out to be a nice number of inches. So I'm going to change. I'm going to say, well, what would that be in centimeters? And in centimeters, it's almost exactly 4 centimeters. Just to make it 4 centimeters, I'm going to make that just a tiny bit bigger. And let's see, that'll still fit. Let me see if that turns out to be right on 4 centimeters. And you know it does. It turns out to be perfectly 4 centimeters, if you can see that. So that means that X is really 35 feet. That X is 35 feet. So up here at the top, I'm going to say, on this drawing, on this scale as it is, 35 feet is equal to every 4 centimeters on my picture. So I'm going to do all my measurements in centimeters. So I guess I'll show you what I'm going to do here so you can see this. So I'm going to take this, and I'm going to say from here, this is from here, this end to this end. I see that as 15 centimeters. So I'm just going to write those dimensions. I'm going to do that all around here. So you'll see me writing the dimensions on this. I'm going to measure along the base, and from this mark to this mark, this was 15 centimeters. I don't think you can see that very well. Let me change the color. This is 15 centimeters. And now I'm just going to measure the rest of them. So now I'm measuring from this mark on the left side down to here. You can see that. Measure that, and that on my ruler is 5.5 centimeters. All right, 5.5 centimeters. And I'm going to go around the rest of the dimensions and measure those. So you don't have to watch me do all this. As you can see, I made some more measurements. This was 5.5, and then I measured this to be about 4.5. Notice I skipped this little part here, and all these measurements in here, I just skipped them. This one, 2, 3 measurements I skipped. And I noticed I skipped this little thing here I didn't skip, and this is why. I don't really want to mess around with these little tiny parts. This is topsoil. I just need a pretty good estimate. So I figured that this piece right here would fill in. It's not quite big enough, but it would probably, the part that I should be leaving out here is a part that I could fill in here and say, well, if I leave that out, I could fill that in with that. And so I'm going to remeasure this measurement. Instead of going all the way to here, I'm going to measure it just to here. That's 3.5. So this is actually, I'm going to lose that and say this is 3.5 centimeters from here to here. And this is why. I'm thinking that this strip from here to here and from here to here, I'm going to use this over here. And so I can make 3 big rectangles. This I'm going to call rectangle 1, the biggest one. This is going to be rectangle 2. And then this portion right here, I'm going to take it and say, instead of worrying about soil there, if that was about this size, now I know this looks a little bigger, this looks a little bigger here than this does here, but I'm still going to use that as an estimate. So I'm going to call this number 2. For some reason this is not staying. And this piece over here, I'm going to call number 3. So I want this measurement from here to here. This rectangle, I'm going to call rectangle number 3. So I'm just going to have 3 rectangles. So that's going to change how I measure. Measure 1 is 8.7 centimeters along this side, but now I need this measurement if I'm going to cut it into those 3 parts. And so if I measure that, that's 4.5 centimeters right here. So rectangle number 1 is 8.7 by 4.5. And those are centimeters though, right? I'm going to come back and change those. Rectangle number 2, I'm going to give a little more space here. That is 5.5 centimeters by 3.5 centimeters. And remember, I just removed this chunk and put it here because we're just estimating, so it doesn't have to be perfect and things don't have to be perfectly rectangular. And then as I measure along the top here, right along here, I'm measuring that, that turns out to be 8.2 centimeters along the top. Oops. 8.2 centimeters. And then the distance from here to here, the width of that rectangle, that is 1.5 centimeters. 1.5 centimeters. So that's number 3. That's 8.2 centimeters by 1.5 centimeters. Now every single one of those I have to change, I know that 4 centimeters is 35 feet, so I'm going to change them all to feet. So what do I have to do to every one of these? I have to multiply by a unit ratio where I have to get rid of centimeters and get feet. So I'm going to put 35 over 4, and I could, that if 4 goes into 35 8 times, that's 8.75 feet per centimeter. So on each of these numbers, I'm going to multiply every one of these by 8.75. That's my unit ratio, my multiplier. So every one of these by 8.75, 8.75, 8.75. And then I'm going to do that calculation and come right back. Okay, as you can see, I've converted every one of those measurements that I made into feet. So this is going to be 76.125 feet actually along that portion, and this is going to be in feet. These are all in feet. And so when you multiply feet by feet, you get square feet. So if I do all those multiplications, which I'm going to do right now, I'm going to multiply all those, I'll have square feet when I'm all done. So these are the calculated areas, and this is almost 3,000 square feet, is this little back area. This is 1,474 square feet, this area right here, which includes this little block that we took out of that, really. And then this top area, that area is only 942 square feet. Now, the question asked us, if you remember, it says soil is sold in cubic yards. And so right now I have square yards, and we do know this. If we're going to calculate something in cubic yards, we would prefer to have all the measurements in yards. And I didn't do that at the foot level because it was just too many decimals there, and I didn't want to do another conversion. But now with square feet, that, by the way, is just the area, not the volume. The area is just what would cover the surface. So that's how much, basically, how much seed you'd need. You'd need seed to cover that area. But with volume, you have to have depth. So we've got a volume to calculate yet to get to cubic yards. Right now we have square feet, and square feet. We could add all those and get the total number of square area in square feet. So let's go ahead and add those three numbers, the 29,997, and of course I've rounded those off, right? 29,997 plus the 1,474 plus the 942. And so that gives us a total of 5,413. That's a total of 5,413 square feet. Well, that's great, but I would like to know what that is in square yards. So recall that this is an area measurement, not a length measurement. So in length measurements, we know that 1 yard is equal to 3 feet. So it's crucial that you understand that when you go from length to area, that a yard is just a measurement of length. So 1 yard would be 3 feet. But if you had a square yard, it would be 3 feet by 3 feet, which is 9 square feet. Okay, so when you go from length measurements to area measurements, you have to consider that it's another dimension. So that's 9 square feet. So if I change this, 1 yard, I have to take the 5,413 square feet and multiply it by a unit ratio that will get rid of square feet and give us yards. So basically I'm dividing by 9, right? So we'll take that 513, divide by 9, and now that gives me 601.4 repeating square yards. And now I'm set up to find the volume. Now this again is area. I have to multiply by the depth to get the volume. So what do I do to calculate that? And by the way, if you just wrote 600, this is just probably more reasonable just to round that off. Now we have the depth. So remember, the volume is equal to the length times the width times the height. And the length times the width is really our area. So that's another way we can think of volume is area times height. And so our area in this case is 600 square yards, and our depth is 4 inches. Well, you cannot multiply 4 inches by yards and expect to get cubic yards. We need to change the 4 inches to yards, just like we changed the... Now this is regular inches, so this is linear. This isn't a second degree. This isn't a two-dimensional. It's one-dimensional. So in this case, 36 inches does equal 1 yard. We don't have the squaring like the area problem, so this is 36 inches is equal to 1 yard. So we're going to reduce the inches. We'll get 4 out of 36 yards, which is 1. That equals 1/9 of a yard. So basically we're going to have that 600 square yards times 1/9. Times 1/9 of a yard. And now everything's in yards, so our answer will be in cubic yards. So 600 divided by, well, I'm going to keep that 601 in my calculator, divided by 9. And that gives me about 66 point something. It says 66.8. I'm going to approximate that at 67 cubic yards for the volume of topsoil that would be needed for that yard. That's all for this lesson. I hope it helps.